All right, guys, I'm just going to walk you through how to do some of the stuff from Chapter 7, section by section. So I'm going to start you off with 7.1, and 7.1 was the section where we did all the graphing. So something like this. I'm going to have us graph y equals 1.5 times 2 to the x plus 1 minus 3, something like that. So remember, you could see y or you could see like f of x equals. That's totally fine. Either notation is fine. So we've got our 3 original points when you're dealing with exponential equations. So you've got a bunch of transformations that are happening here, and I purposely did one where you've got every possible transformation happening at the same time. So the 1.5 out front, remember that is going to stretch your graph by a factor of 1.5. This is going to shift your graph 1 unit left, and then this is going to shift your graph 2 units down, all starting from our base of 2. So every time that we graph these exponential functions, remember you are going to start with your original points, and your original points are always these. You would have -1 and then 1 over the base. Every exponential graph has 0, 1, and then you would have 1 comma b. All right, so b is the base. Here the base is 2. So our original points are -1 and then 1/2, 0, 1, and then 1 comma 2. So these are the originals. We're gonna, in the next round, write what the transformed points would be, and then we will plot them. All right, so this, the x plus 1. Remember, if it's in the x, if it's in the exponent like that, it always does the opposite of what it looks like it's going to do. So we're gonna subtract 1 from all of our x values. So here are our new points. So subtract 1 from that x value, subtract 1, and subtract 1. Okay, so those are our new x values after our graph got shifted. And then the next thing that we have is both of these things are going to affect the y. So remember, you go from left to right. First, you're going to multiply the y values by 1.5, and then you're going to subtract 3 from the y values. Okay, so 1.5, you can think of it like 3/2 if you want to. So 1/2, if I multiply that by 1.5, then that's going to give me 3/4, and then subtract 3. Okay, so 3/4 minus 3 would be -2 and 1/4. Okay, and then starting here, 1 times 1.5, and then minus 3 would be -1.5. Here, 2 times 1.5 is 3, and then minus 3 would be 0. So those are going to be the new points. I'm going to plot them, take a look at what the graph looks like. Okay, so -2, and then -2 and 1/4. So here's -2, and then -2 and 1/4 would be, just a little bit beyond that. -1, -1.5, be about there, and then 0, 0, right at the origin. Okay, so remember, another really important feature of these graphs is to make sure you have the proper asymptote. The asymptote is going to be at -3. It's always just whatever number's hanging right here. If there is not a number there, then it's just at 0. Okay, so extend it as far as you want. Your graph is going to just skim right along that horizontal asymptote and then go through these points. And that is exponential growth, and that's because 2 is bigger than 1. If you're dealing with a fraction, it would be exponential decay, and it would shrink as you go from left to right. But other than that, the process is going to be exactly what I just did here.